Hello, gang. Unit 4, Day 3. All right, if you're watching this, either you're quarantined or might have needed a extra reference. All right, so either way, thank you for joining us. Okay, and so let's get started. All right, so a lot of times, for those of you that decide to take some sort of mathematics career, okay, you will find that we're always manipulating expressions and stuff like that algebraically such that we get it written in a certain manner, okay? So going back to last unit when we were talking about like quadratic equations, right? We had those three different forms, right? And we were going from standard form, converting it to vertex form. Why did we do that? Well, we just wanted to answer questions about the vertex and stuff like that based off that form, right? So it drove, our process kind of drove what kind of answers, or I'm sorry, what kind of, well, what we're, I don't know, I forgot my train of thought. But anyway, all right, so what we're trying to do here is, again, we're just trying to manipulate these expressions so that they're written differently, and then eventually throughout this unit, you will see the usefulness of this, all right, when we are forced to, solve for exponents and stuff like that. We're going to need to be able to utilize these exponential rules in order to manipulate our expressions in order to represent them in a different manner. Now, key word here is equivalent, okay? So what that means is that these expressions are equal to each other, right? For something to be equivalent, they need to be the same, right? So just keep that in mind, right? So these are the same expression, right? Just like when we had those quadratics in standard form and vertex form, right? That's the same, graph, right? The same expression, just represented differently, okay? So hence the name equivalent. And yeah, so anyway, let's get started. So what are we trying to do here? Well, we're trying to rewrite these expressions such that it's in the form of some number raised to the t. Okay, so if you look at number 1, we have a t here, but we got this pesky 2 sitting in the front. Okay, and so what we can do, right, is we can kind of move this 2 inside the parentheses and leave that t on the outside. Right, now why would I do that? Well, because our instructions are telling us to get it so that we have some number raised to the t power. And so by moving that 2 in, well, 8 is actually a number, right? 8 squared is just 64. And so we end up getting 64t. Okay? And again, we didn't break any rules here, right? Because if I wanted to get back to where I was at, I would just multiply this t with that exponent inside there, okay? So again, these are the same expression. So if I put in a value for t, right, so let's say t is equal to 2, right, so 8, 2 times 2, and 64 squared. Right, well, this one's going to be 8 to the 4th power, which I don't know what that is off the top of my head. Hold on a second. Let me grab my handy-dandy calculator here. All right, so 8 raised to the 4th power is 496, and 64 squared is 496. Okay, so again, these are the same expression. Okay, let's move to the next one. So the next problem. Okay, very similar. We got a t here, except we got this 2 sitting in the denominator now. All right, now the process is still the same. Okay, this is actually t, 1/2 times t, right? That's what that t over 2 stands for. Okay, and I'm going to do the same thing I did over here, and I'm going to move that 1/2 inside the parenthesis. Okay, and again, I multiply this through, right? Power raised to another power. I would multiply the exponents. I'd still get the same thing up there, right? Now, however, right, 16 raised to the 1/2 power, okay? Might not all remember what that means, but anything raised to the 1/2 power is the same as taking the square root of that number, okay? So, that being said, all right, what's the square root of 16? 4t. Let's take a look at number 3. Okay, number 3 and number 1, very similar. We take that 3 push it inside the parenthesis there. And now we end up with 125t. And finally, same thing like I did in number 2, except now we got 2/3 power, right? So I'm going to take this 27 raised to the 2/3 times t, right? And I'm going to push that 2/3 inside there. And I think that's a 9, if I'm not mistaken. 27 raised to the 2/3 power. 9t. Okay? So again, the reason why we're doing that is just because, well, the instructions told us to. Okay? But these are still the same, they're equivalent expressions, right? They're just, they're just represented differently. Okay? So let's take a look at number 5. So number 5, okay, again, plays a little more with our exponent rules. Okay? So if you recall, right, when we have x squared times x cubed, right? So we have the same base. So what do we do with our exponents? Well, we just add them. So that's going to be 3 plus 2, which will give me, whoops, not 5, x to the 5th, right? Okay? But what's really going on here? All right, what if, for whatever reason, it was x to the t power? Okay, well then our answer would just be x t plus 2, and we would just have to leave it like that. So that's kind of what we have up above here. All right, whoops, that would be a 3, sorry. Right, but anyway, okay, kind of like what we have up above here. Okay, so here I have a 2t times 2 to the first power, right? Okay, so if I were to multiply these back through, I would have the same base, okay, add the exponents, and you would get t plus 1. So now, what are we trying to do here? We're trying to rewrite this expression such that it's some number times some number raised to the t. So we almost have that here. All right, and our problem is that it's just written backwards. So I'm going to move that t to the first power in the front and leave it like that. Okay, that's number 5. Number 6, very similar, except now we got 5 to the negative 1 power. Move this out of the way here. Okay. And if you recall, 5 to the negative 1 power is just 1 over 5. But again, I'm trying to get it like this form right here. So I move that 1 over 5 to the front. And you have to make sure that you do that because that's what the instructions are telling us. If you left it like this, they're going to mark it wrong. Okay? So just keep that in mind. Okay? Follow the same process over here, except now we got an extra number in the front. That's okay. That's what we got here, right? So technically, if we wanted to, right, this would actually be 7 to the t plus 2 power, right? And so this is just 7t. I'm sorry, that's a 2, right? 7t times 7 raised to the second power, which gives me 7t times 49, and then move that to the front. And so we get 49 times 7t. Okay. Let's try this next one. Again, just have an extra number in the front. 8 to the t and 8 to the negative 1. Okay? So, remember, right? This one doesn't have to be as difficult as you think, right? If we were to multiply all these back through, we would add the exponents, right? But when I got a 1 and a negative 1. So when I add those exponents, what do I get? actually get 8 to the 0 power, right? Okay. So, or if you recognize that this is just 8, and this is just 1 over 8. So when I multiply those together, what do I get? I just get a 1, right? And remember, anything raised to the 0 power is just a 1. But we have to include that 1 there, right? Because we need to make sure that there's some number out front, right? So if for whatever reason you get stuck, you're like, man, I got this 8t, but there's no number in the front. That's because it's just a 1. Right? And 1's one of those things that doesn't affect the outcome of anything, right? So nothing too crazy there. Okay, the last 3 problems. All right, so I'm going to leave this 6 out in the front. This is going to be 3 to the t times 3 to the negative 1. I'm just going to separate all these out here. 3 to the t, 3 squared, 10 times 4. I'm just going to move that 1/2 inside, raised to the t, and then, ooh, that one's going to take some work here. So we'll come back to that one. Okay, so let's stick with these first 3 first, okay? So remember, this is just 1 over 3. So 1 over 3 times 6 is just going to give me a 2 times 3t. Here we already have the 3t. So I'm going to multiply 3 squared and 9. And 3 squared is just 9, so it's going to be 81 times 3t. Okay, next one, it's going to be 10 times 4 to the 1/2 power, or the square root of 4, which give me 2t. And so finally, last one here. Okay, I'm going to leave this 8 alone for a second. So we're going to bring this 9 out, and then times 9 to the negative 1. Okay, that's your first step. Okay, you want to make sure that you're not doing anything with that 3t until we get all of these operations dealt with. Excuse me. So in this case, we got a negative 1 there, right? So let's break that up, right? Remember, this is just 1 over 9. Okay, so I'm just going to move that to the front. So I'm going to have 8/9 times this mess right here, right? So what are we trying to get left with? What we're trying to get left with is that just a t. Okay, so 8/9. I'm going to take this 9, I'm going to move that 3/2 inside the parenthesis, raised to t, and I believe 9 raised to the 3/2 whoops, is 27. So 8 over 9 times 27t. And there's all the problems, okay? And remember, you guys are responsible for the odd ones. Okay, so that is a total of 7 problems. Okay, good luck, you guys.